In this video, we're going to look at how to simplify radicals. So you're going to get a problem that looks like this. Simplify the square root of 180. So remember, square root means, can you tell me two numbers that are exactly the same that multiply to be, in this case, 180? The closest perfect square to 180 is 196 or 169. 180 is not a perfect square, so you can't square root this and get an exact value without a calculator. And even then, a calculator will only give you, the first 9 or 10 digits of the decimal. So what they mean by simplify is, can you write this in a different way, maybe with a number smaller than 180? So that's what we're going to do. What you need to do is you need to look at all the perfect squares and find the biggest perfect square that you can find that will divide evenly into 180. So, working backwards, 14 squared is 196, 13 squared is 169, 12 squared is 144, 11 squared is 121, 10 squared is 100, 9 squared is 81, 8 squared is 64, 7 squared is 49, 6 squared is 36, 5 squared is 25, 4 squared is 16, 3 squared is 9, 2 squared is 4, and 1 squared is 1. So from this list of numbers, we want to find the biggest one of these that can divide evenly into 180. So obviously it's not going to be 196 because that's bigger than 180, right? So what's the biggest number here that will divide evenly into 180? I'm thinking it's going to be, well, it could be 100, but probably not. No, because 100, 200, 81, 64, 80, 49. If you're not sure, just grab your calculator and start dividing. 180 divided by 81? No, that's 2.2 repeating. It's not that. 180 divided by 64? No, that's 2.8125. It's not that. How about 180 divided by 36? There we go. So 180 divided by 36 is 5, right? So what you're going to do, instead of writing 180, I'm going to write 36 times 5. Now, am I allowed to do this? Am I allowed to just take a number and split it into two different square roots like that? Well, actually you are. You're allowed to do this because these two problems here are actually equivalent. And since 36 times 5 is 180, all three of these problems are equivalent. We know that 180 is 36 times 5. And I'm telling you that 36 times 5 being 180 means that you can split this into two separate problems. And why would you want to split it into two separate problems like that? Well, one of these, since this is the list of perfect squares, one of these can be square rooted, right? The square root of 36, we know the answer to that, it's 6. Right? So this 180 can be simplified to be written like that. 6 radical 5. And when I say radical, in case you don't remember that square root symbol, another name for it is called a radical. All right, I know I'm done when the square root is a number that's not on this list or it can't be divided by a number on that list. The only two choices here are 4 and 1. And yeah, I know 1 goes into 5, right? But we're going to end up right back where we started when you deal with the 1. So really the 1 is not helpful to us in this situation at all, right? All right, so let's do another example. Let's simplify the square root of 128. Now, I just told you should pick the biggest number from this list and see the biggest number that goes into 128. But maybe I'm not sure which numbers go in, so I'm just going to pick the smallest number I can that goes in. So I'm going to pick 4. So 128 can be divided by 4 how many times? Well, 128 is divisible by 4 32 times. And the square root of 4 times the square root of 32. Hey, the square root of 4 is 2, so that's answered, right? And the square root of 32 is just going to be brought on down. Now, I picked a smaller number than I should have here because the 32 is a pretty big number, and guess what? It's divisible by 4 and 16, right? So by picking a number on the list that was near the bottom, I didn't do all the work in one step. I didn't finish the job with 4. 4 wasn't the best number I could have picked here because 4, although it does go into 128, it left 32, which I can also simplify. So I just have to do it all again. This time I have to do with the 32, and I'm going to do 16 and 2. So what I'm saying is, you don't have to pick the biggest number from the list. You can just pick any number from the list. But if you don't use the biggest number from the list, then you're going to have to do more steps because your radical that you get is not going to be fully simplified. So you should always try to pick the biggest number you can pick. The square root of 16 is 4. So I'm going to put that out here with the 2 that's just kind of floating out there. So my final answer here is 8 radical 2. There was a 2 out here, and then when I square rooted the 16, the 4 joined the 2 out there as a multiplication problem. And radical 2 can't be simplified. So going back to my original situation here, 128 is divisible by 64. I should have just picked 64 from the start, and then I would have been done right away. But because I didn't pick the biggest number on the list, I still got the same answer. I just had a lot more work to do. All right, let's do one more example here. Let's do actually, let's do this example. Let's do this example here. 4 radical 135. So sometimes when you're simplifying these, there's going to already be a number out front the radical. And this is just a plain old number. That's a constant just out front, like a coefficient. It's just there waiting to multiply anything else that might come out there with it. So what is the biggest number from our list that goes into 135? Well, since it ends in 5, I know that it's probably going to be a number that's divisible that also ends in 5 or maybe 0. So 25 doesn't go into 135. 25 goes into 125. So, let's try 135 divided by 36. No, that's 3.75. 135 divided by 9. Oh, there we go. 139 divided by 9 is 15. So 4 times 15 times 9, right? 15 times 9 is 135. I can split this apart into 2 square roots, and I can answer that one. 4 times 15 times the square root of 9 is 3. And then 4 times 3 is 12. And square root of 15 is a double-digit number, but it can't be simplified because the only numbers that go into 15 are 1, 3, 5, and 15, and none of those are perfect squares. All right, so that's our examples for today. Thank you for watching.